When you're writing asynchronous code in C#, you're going to come across a choice. And it seems so small, just one little word in your method signature. But believe me, it can have absolutely catastrophic consequences for your app stability. Today, we're diving deep into that critical choice, async task versus async void.
All right, let's kick things off with the core problem, the async question. Now, this isn't some obscure, nerdy debate. The question you're looking at right now, it's been viewed on Stack Overflow over 650,000 times. That's a ton of developers trying to figure this out. The assumption is often, oh, it's just about tracking progress. But the real answer? Well, it's so much more important and goes right to the heart of keeping your application from crashing.
And that's exactly where we're talking about this. This isn't just about a preferred coding style or some minor convention. This is about stability, period. Your choice here directly controls how your application deals with errors, and ultimately whether it stays up and running or just falls over unexpectedly.
So let's get into it. Task versus void, the showdown. To really get what's going on, we need to look at the 3 different ways you can write an async method. So async methods can basically make 3 different kinds of promises. You've got async task T, which says, hey, I'll be back in a bit and I'm going to have some data for you. Then there's async task, which is a little simpler. It just says, I'll be back, I'm not bringing anything, but I'll definitely let you know when I'm done. And then there's async void. This one makes no promise at all. It just goes off and does its thing and gives the code that called it absolutely nothing to track its progress. No wonder it gets called the nasty one.
This table, right here, tells the whole story. With async task, you, the caller, you're in control. You can await the operation, you know when it's done, and, this is the big one, you can handle any errors it might throw. But with async void, you're basically flying blind. You can't await it. You have no idea when it's finished, and as we're about to see, that no next to propagating exceptions, well, that's where things get really dangerous. And that brings us to the most critical difference of all, and the main reason async void is just so risky. It all comes down to what happens when something inevitably goes wrong. This quote is everything. It's the key warning. When an async void method throws an exception, that error has nowhere to go. It just bubbles straight up to the thread pool. And since way back in .NET 2.0, an unhandled exception there is a fatal event. We're not talking about a logged error. We're talking about terminating the entire process. Your app is gone. Poof. Now, async task, on the other hand, it's got this built-in safety mechanism. If an exception happens, it gets neatly captured and tucked away inside the task object itself. The code that called it can then just await that task inside a totally normal try-catch block and handle the error gracefully. It's predictable, it's controllable, and it's safe. With async void, that safety net is just gone. There's no task object to catch the exception, so your try-catch block has nothing to grab onto. The error has no other option but to erupt straight onto the thread pool, and in most apps, that means your whole program just dies. And this isn't just theory. This is a real-world horror story. A developer had a web API controller that just kept crashing. Why? Because it was async void. The web framework saw the method return instantly and went, okay, I'm done here, and got rid of the database context. But the actual database call was still chugging away in the background. The fix was as simple as changing void to task. That one single word was the difference between a stable API and a bug that brings down production.
Okay, so let's move on. This all leads to something people call the fire and forget problem. And, the name sounds kind of convenient, but the reality is anything but.
This quote nails it. Using async void is like launching a missile and then immediately turning off all your tracking systems. You fire it and you just forget about it. You have no idea where it is, what it's doing, or when, or even if it ever hits its target. You're just hoping for the best.
And this loss of control has a real consequence. When your async void method returns, the only thing you know for certain is that the little bit of code before the first await has run. The rest of it, it's off on its own adventure, and you have no way to know when it finishes or if it even succeeded. You have totally, completely lost control. Okay, so after all this doom and gloom, you're probably thinking, right, I get it.
Never, ever, ever use async void. But there is one major and really important exception to that rule. So the one place where async void is not only okay, but actually necessary is for event handlers. Like a button click in a Windows or a mobile app. The way those events are structured, their signature requires a void return type. You literally can't change it to return a task. This is the one job async void was actually designed for.
So why is it safe here but not everywhere else? The magic trick is something called the synchronization context. You can think of it like a special safety net that UI frameworks put in place specifically for these async void methods. If an exception gets thrown, this context catches it and gently passes it back to the main UI loop. This lets the error be handled just like any other, and it prevents that catastrophic application crash we see everywhere else.
All right, section 6, the golden rule. We've seen the danger, we've seen the one single exception, so what is the one thing you absolutely have to walk away with? It all comes down to a single, simple, powerful rule.
And here it is. If you remember absolutely nothing else from this entire explainer, remember this. Always prefer async task over async void. This is your ticket to writing async code that's testable, that's maintainable, and most importantly, that's stable. So let's just boil it all down one last time. You use async task anytime you need to do something async that you want to wait for or track or that might throw an error, which, let's be honest, is pretty much all the time. And you save async void only for those top-level event handlers where the framework is giving you that special safety net. And that leaves us with one final, pretty important question for you. We've seen how a seemingly innocent async void can be a little ticking time bomb hidden in your application. So where's one hiding in your codebase right now, just waiting for the right conditions to go off? Thanks for watching The Explainer.